Welcome, ladies and gentlemen, to your PN38 notes, which is all about the law of cosines. This is section 5.6 in your textbook. And we just got done doing the law of sines, so this is kind of works right along with that. So I'm kind of on a roll with making videos, so I figured I'd do this one for those people that are really solid with the law of cosines. It says, why do we need the law of cosines? Well, first of all, if you have, again, a non-right triangle, you can use the law of cosines if you have technically more sides than angles. At least that's how I always think of the law of cosines. It doesn't work as straightforward as that, but really when you have more angles, you tend to use law of sines, and more sides, you use law of cosines. Okay, so let's first of all sketch the triangle, just like we did in our last note guide. We have angle A, B, C. It's solved for the missing parts. If side length A is 11, C is 14, and B is 34 degrees. Ooh, that's written poorly, but the law of cosines goes a little something like this. It's really a derivative of the Pythagorean theorem, where it's derived from the Pythagorean theorem, where we have a squared equals b squared plus c squared minus 2bc cosine A. And I know that you guys have seen this, so and you've all had different experiences with this. Some teachers may have actually shown you how to prove this. And if you haven't had that experience and want to see how these formulas are proved or were created, I would love to show you that. So just let me know. Okay, I'm writing it out. I want to make sure I don't mess up. Notice I am putting my cosine A, cosine B kind of off to the right, just so that you don't think this C right here is, I just want to make sure you see the difference here. Like for instance, this is cosine A, there's multiplication in here, and that C right there is obviously the length of C. Same thing here, just the note guides are important to make sure you have them right. And that's not going to be an issue for this one because we have c squared equals a squared plus b squared minus 2ab cosine c. And I never usually write these all out because really they're all the same kind of format. You can kind of see that. And just to be consistent, for those of you who are a little weird about things, let me just be consistent. And again, this is multiplication in here. All of it's multiplication. Okay, so coming down here, let me switch back over to something less obtrusive. It says solve the triangle from above using the law of cosines. So if you look at this, you have the angle B, so you're going to have to use, I mean, if you want to get fancy, you're going to end up using this one right here. So if you like plugging, chugging, great, do it. But otherwise, what's really happening is you're finding this length right here, so you're going B squared equals, oops, again, I could be a little less sloppy, equals 11 squared plus 14 squared minus 2 times 11 times 14. I'd put them in parentheses so it doesn't get all messed up. Cosine 34 degrees. This is the best part of the law of sines when you're actually finding the length versus an angle. Students tend to not get this wrong, but you have to be really careful with your order of operations. I'm just telling you, like, you know this is 121, you know this is 196, and then what I do is I do this all in one great big swooping motion, which is minus 255.3436. Notice I go 4 digits out so that when I round at the very end, it's not going to be a problem. I mean, honestly, you can do it all in one great big motion. Just be careful, though. So you end up with b squared equals 61.6564. You take the square root of that. And since the length can only be positive, that's why we don't have to worry about the plus or minus. So you end up with 7.852. Okay? And then honestly, then I'm done using law of cosines. I gotta tell you, as fast as I can get away from the law of cosines, the better, in my opinion. So I'm going to right now switch over to the law of sines. So I'm gonna go, oops, I can't see my triangle, and I just wrote on my other thing. There we go. So now I know my side B, so I'm going to go sine of 34 degrees over 7.852. Listen, I was just like making sure that I. Yep, okay. Just want to make sure I have that right. Equals sine of A over 11. And I'm going to have to talk to you about something that's kind of important here in just a minute, but I'm kind of on a roll, so let me just kind of keep going here. So we have sine of A will equal 0.783. Do your inverse sine, and you can find that your angle A is equal to 51.536 degrees. Now, what I was going to say up here is, and it's kind of a pain because my triangle's up here, is that I could have found angle C first. I could have found this before angle A, but I didn't because I want to use the law of sines, and the law of sines will only give you an acute angle. And I don't know, since this is the biggest side length, and so angle C is right across from the biggest length of side, which means it's the biggest angle. I don't know if it's an obtuse angle or not. And because of that, I won't get the right answer with using law of sines by picking the largest angle if it's obtuse. So again, I know they covered that last year in advanced algebra, but it's kind of one of those things, always with the law of sines, if given the choice, find the smaller angle. So you need to find the smallest angle. Never the largest. How's that? Just never find the largest angle first. Because here, watch this. So we have side B, we have angle A, and now we need to find angle C. And of course, we know the two angles in a triangle. Take it away from 180, and you'll find that angle C is 94.464 degrees, which is hugely, that's an obtuse angle, and obtuse angles can never ever be found with using inverse sine. So this will always give you the angle in that first quadrant, really, is what's happening. So you need to be careful of which ones you're picking. Let me see if there's anything else I need to say. So law of cosine is pretty straightforward. Just be careful of your order of operations. When you're doing law of sines, always pick the smallest angle that you need to find. And the other thing is I know this is not an ambiguous case simply because we would have all three side lengths. So there's no fluctuation, there's no other triangle that it can be. So this is not an angle side-side situation. Actually, this is a side-side-side with an angle. So that's makes that triangle very definitive as to which one it is, or what the solution is. Okay, so there's my solution. I'm sorry, wrote right over my next problem. It says solve for all missing parts of triangle ABC, given those three side lengths. In addition, find the area of the triangle. I'm going to say, just for time's sake, I'm going to get rid of this part, okay? We can do it, but you know what? I don't want this video getting any longer than it already is going to be. So we have triangle A, B, C. Actually, my battery on my iPad's almost dead, so I have to be careful. So angle A across from that is length 9. Because of that, B is 7 and C is 5. So this is a side-side-side angle, or triangle, excuse me. And really, we have no angles, which means that we obviously can't use the law of sines. So again, what I always think of is that when you have more angles and sides, that's when law of sines kicks in. Cosines tends to be related to sides more. So the very first thing I'm going to do here is use my law of cosines. Okay, and this is the one that students get messed up on, and it's not that it's difficult, it's just okay, I need to stop talking too much. Okay, so we have 9 squared equals 7 squared plus 5 squared minus 2 times, and again I'm just using my law of cosines here, times 7 times 5 times cosine of A. And I know this is where I chose to find the biggest angle, because law of cosines, you can do that. You cannot do that with your sines. So I can't say that again enough. So again, you could have, for law of cosines, you could have found angle B or C as well. But what I'm choosing to do is the biggest angle, this one right here, which is across from the bigger side, because law of cosines doesn't have any issues. If you do choose law of sines, just don't find the largest one. So if all of a sudden you chose to do, because you forget the rules, you can't remember if you should use law, you can find your biggest angle or not, well, find the smallest one, then the second one, but just don't, with law of sines, just don't use, find the biggest one. That's the problem. So law of sines, just as a reminder, don't find largest angle. And the only reason is, don't find largest. The only reason is because when you use your inverse sine on your calculator, you cannot get an angle over 90 degrees. It just doesn't happen. Okay, so here we go. So when you do this, you end up with 81 equals the 7, when I combine these two, I end up with 74, minus, when I combine these, I end up with 70 cosine A. This is where people really like combining the 74 minus the 70 and saying it's 4 cosine A, and that is the naughtiest thing you can do, so don't do that. Order of operations says that you first have to, and I'm going to even do this in red because this is the number one mistake I see, is to subtract 74 from both sides, and then you end up with 7 equals negative 70 cosine A. Now you divide out that negative 70, which gives you cosine A of negative 0.1, and then when you find your angle doing your inverse, you can do it and get 95.739 degrees. And again, if this kind of freaks you out to get a obtuse angle, find the other two first and then subtract those two from 180 degrees. It's all good. So at this point, what I'm going to do is I'm going to switch definitely over to law of sines because I try to avoid cosines as much as possible just because it's tedious. But again, just be really careful with this spot right here because this is where students want to combine those, and those are not like terms because this is a term which has a cosine A on it, and this one does not have a cosine A. So you cannot combine those two. You have to subtract 74, then divide out by negative 70. Okay, so we have one last step here. We have sine of 95.739 degrees over 9. Now, this is an obtuse angle, I get that, but you're not trying to find an obtuse angle. You can evaluate an obtuse angle. That's not a big deal. But we have that over 7. Cross multiply, solve. You'll end up with an angle B of 50.704 degrees, and then of course you can, so here's one of my angles up here, sorry about the mess, I'm getting frantic because I don't want my iPad to die, and then angle C is going to be 33.557 degrees because of the 180 rule. Okay, so that is law of cosines, and really the back of this note guide is super fast. Which law do I use? Well, here's the thing. Law of sines is most of them. When you have angle, side, angle, angle, side, and even the angle, side, side, but that's the one where you have ambiguity, right? This is, you have two solutions. This is law of sines. Notice all those angles. When you have, except for, of course, the ASS, and the ASS has two solutions. So that's where I always say, you have to always be careful with that law of sines when you have too many sides. Side, angle, side, 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 side is the law of cosines. Again, notice, I forgot of there, law of cosines. And then last but not least, the right triangle, right? This is Pythagorean theorem. And SOHCAHTOA. And I'm getting speedier as I go here. Side, 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 find the biggest angle first with the law of cosines, because that doesn't cause any issue. Again, law of sines does not have the power to tell you an obtuse angle. And really, we'll talk more about this in class because we'll kind of explore that and kind of explain why that's happening. It ends up going back to the unique solutions of that last 2 chapters ago, where it's always in quadrant 1 and 2 versus quadrant 1 and 4. But we'll kind of go back to those note guides and make sure you remember that. With law of sines, always check for more than one triangle when you have ASS. Okay, which law should I use? Well, here we go. We have, and if it helps, draw out the triangle, but notice you have 2 angles here and a side. That's definitely law of sines. Which one is this one? Notice you have 2 sides and an angle, but I'm not quite sure, so let me just double check. This is A, B, C. This is 6, this is 4, this is 85 degrees. Look at, you do have a side directly across from that angle of 85 degrees. This is that ASS. By the looks of it, let me just kind of look at this really quick. And we're going to use, the law of sines. All of a sudden I was just looking at that again. Keep going down here where we have 34 degrees, 74 degrees, and 5. Here's, again, you can draw it out if you want. Here's A, here's B, here's C. And this is 34 degrees. This is 74 degrees. And we have this length over here of 5, side angle side, right? So you end up with law of sines again. This is not very interesting, is it? Okay, so I'm going to actually say something. This right here is ass. You know what I mean? This looks like it's a ambiguous case, and actually I wrote it on my note guide as ambiguous. But then I looked at this a little bit more, and I'm going to let you know this is not an ambiguous case. And I want you, and we're going to talk about this in class, I want you to look at it and tell me why it's not an ambiguous case. So this is kind of an oddball one, and this really gets into what an ambiguous case is. And remember, this is 85 degrees across from side 6. This is side 4, length 4, and this angle, you can pretty much look at it and kind of decide what type of angle. So this here, be ready to explain to me why that's not an ambiguous case, even though it's very much looks like it. And actually, look at, I really said it, and then I'm like, no, this isn't an ambiguous case. It looks like it, it follows the ASS rule, all that stuff, but specifically look at the triangle and see if you can see why that's the case. Okay, so again, this is section 5.6. And the homework should go pretty well as long as you're remembering the ambiguous case. And again, always find with law of cosines the biggest angle, and with law of sines, not the biggest angle, bottom line. Okay, we'll take any questions you have in class. Thanks for tuning in.